Hey guys, welcome to our asynchronous session on piecewise functions. Piecewise functions are something I always try to cover with my students because a lot of people have questions about them. But the thing to remember is that a piecewise function is simply a function that's broken up into parts. So you're just graphing one piece of the function at a time. And each piece is something you're familiar with. It might look like a line, it might look like a parabola. So you just have to figure out what that one piece looks like, get it on the graph for the part of the graph that it needs to be on, and then move on to the next piece. Okay, so I have an example here, which is, oh, I forgot my f of x. Just realized that. Let me get that on here. Okay, there we go. So this is our whole function. It has two pieces. It has this first function and a second function that's part of it. This part over here, the x is less than 2 or x is greater than or equal to 2, that tells us kind of the directions about where to graph that piece of the function. So I'm only going to graph this first line. We notice it's a line. It has an exponent of 1 on the x, so it's linear. So when I graph this line here, I'm only going to graph it for any x values less than 2. Okay, so this is where x is 2 right here. So it's like over on this side of the graph, I'm going to be graphing y equals x plus 1. Excuse my handwriting a little bit over there. And then on the other part, for x is greater than or equal to 2, I'm going to be graphing y equals negative 2x plus 7. This is a y here. Okay, so I'm graphing a line over here somehow, but then that line's going to stop when I get to 2. Then I'm going to graph my other line over here. Now it's kind of up to you how you want to do this. You can use the slope and the y-intercept of each line to graph, or you can make a table. A lot of people find it helpful to make a table, so that's what I'm going to show here. Okay, so I'm going to go ahead and color coordinate a little bit so that it's easy to follow my work. Let's go ahead and do red. Okay, so for x plus 1, I'm going to be plugging in some numbers, and I can only plug in numbers that are less than 2. So I'm going to plug in, say, 0, 1. I am going to plug in the number 2, but we'll do something special for that number because I technically can't be the number 2 for this function because I'm not equal to 2. Okay, so I'm going to plug in 0. 0 plus 1 is 1. 1 plus 1 for the next x value of 1. 1 plus 1 is 2. Plug in 2. 2 plus 1 is 3. So now I have some points I can go ahead and graph. So again, just graphing on this side, y equals x plus 1. I got a point here. I got a point here. I don't really have a point here because this one is special. When I plug in 2, I'm technically plugging something and I'm not allowed to. But we need to know the stopping point. And so we're going to mark that point with an open circle, okay, 2, 3. So I technically would go all the way up to that point, but I don't actually reach it and fill it in. So just like when we did inequalities with number lines, we use open or closed circles to indicate if there's an equal sign for the inequality. For this one, since there's not, I use an open circle on that point. And then I've got this nice little line here going down with a slope of, well, it's actually going with a slope of 1 up and to the right and a y-intercept of 1. So that's that first part of the function that I've graphed. Now let's go ahead and do green. So I'm going to graph this next one, y equals negative 2x plus 7. And I'm going to plug in some numbers in my table that are greater than or equal to 2. I am going to start at 2. Because that's a good starting point. We always want to know what's going on here at the break at 2 for x. And then I'm going to plug in 3 and 4. So just plug in a few numbers to get an idea of what's going on. So plugging in 2, I'll go ahead and show all my work here. Negative 2 times 2 plus 7. That's negative 4 plus 7, which is going to be 3. plug in 3, so I'm going to do negative 2 times 3 plus 7, that's a times. Negative 6 plus 7 is 1. Plug in negative 4, negative 2 times 4 plus 7, negative 8 plus 7 is negative 1. So on this one, we are going to have a closed circle because I'm allowed to be 2 when I plug in my 2 for x. Remember on this one, this was our open circle. So it might help when you're doing the table to actually go ahead and identify which one is the open and which one is the closed circle. So I've got 2, 3. Looks like I have a point here. So even though I didn't before, I can now go ahead and fill that in because I do have a point there for my other function. 3, 1, and 4, negative 1. So this one has a slope of negative 2. See that in the function? It would have a y-intercept of 7, but we don't get to graph that y-intercept because our function isn't using this equation over there when y is 0. So this is it. My graph has 2 pieces. They're both lines, and they're created using those 2 equations, and the break happens when x equals 2. Okay, so that's it for my first piecewise function. We're going to do another one in a second that has a quadratic, and then you'll be ready to try these on your own.